in this video, we're going to go through a couple examples of a dependent t-test. So this first one I have pulled up. Here's the background. A researcher wants to determine the effectiveness of using certified therapy dogs as a treatment for stress relief. So they're going to use a pre-test, post-test design. So it's a step one, pre-test. First, the researcher will escort each participant to a comfortable chair in a clean, quiet room and allow the participant to settle for 10 minutes. Next, the researcher will record the participant's resting pulse rate, and this will constitute the pretest score. Step 2 is the treatment. The certified therapy dog will be brought into the room and introduced to the participant. The participant will be told the dog's name and briefed that he or she may pet or brush the dog if desired. Step 3 is the post-test. After 30 minutes with the dog, the researcher will take the participant's pulse, and this will constitute the post-test score. So this is a repeated measure because the same participants are being given a measure twice, in this case their pulse rate. So it is a dependent T. So the hypotheses in this scenario, the null hypothesis would be that pet therapy has no effect on the pulse rates of stressed people, and the alternative hypothesis is that pet therapy reduces the pulse rates of stressed people. So since we have that word reduces, we're looking at a one-tailed dependent T. So I'm going to show you how to do it now. Here's SPSS. We have the names of all our participants right here. It could have also been a number or a code. And we have their pre-test scores and their post-test scores. Each one is its own column. So to analyze this, we go up to where we always do, analyze, compare means. But over here, this was where your independent sample t-test was, but now we're going down here to paired samples t-test. So all we have to do is put these two variables into these two slots. Okay? The order you do it doesn't matter. I could do pre-test first and post-test second. If I did it the other way, it would be fine. It would just change the sign on my T. So because your readers don't know which one you put in first and which one you put in second, that's why it's really important that you always tell them in your text which group was higher, and then don't worry about the sign on T. Options here are just for the 95% confidence interval. You wouldn't have to worry about that. See, really simple. So we say, okay. Now I'm going to go to my output screen, and it says here that we ran a t-test. Up here, paired sample statistics. It tells you the mean for the pre-test score and the mean for the post-test score. It gives us our ins and our standard deviations. So we can see here that the mean did go down. That was what we hypothesized. So we're going to go see if that was significant. This table, don't worry about that. That just tells you whether or not your variables were correlated with each other. And we want them to be correlated, but that's nothing you have to report. So don't worry about that table at all. So we would just delete that essentially and not worry about it for you. So now, paired samples test, it tells you right here that it did pre-test minus post-test. So it took this 88.31 and it subtracted 86.56. That's all it did. And then it told you what that difference was. The difference was 1.75. Okay, that's positive, which means the pre-test was bigger. So these means and standard deviations are the difference, the mean difference and the standard deviation of the difference. So don't report those. Report these means and standard deviations. If you were to report a 95% confidence interval, it's right here, but I'm not requiring you report those. Instead, I care about this. In this case, T is 2.61. The degrees of freedom is 63. And the two-tailed significance is 0.011. But we didn't want a two-tailed test, we wanted a one-tailed test. So what you have to do in this case is you have to take that P, 0.011, and you have to divide it by 2, which equals 0.0055. Okay. If we were to type this up, let me just show you what we would do here. So we might say T, and we'd want to italicize that for APA. Oops. Sorry. And the degrees of freedom goes next, which is 63. That should not be italicized. equals 2.61, 2 decimal places. And we would just say P is equal to it was 0.0055, so we round that up to 0.006. And then that P should be italicized. Okay? And then you would just calculate a Cohen's d and say what that equaled. Okay? That's all there is to it. Cohen's d, you could again calculate it, this divided by this, which in this case would be 1.75 divided by 5.36. In this case, Cohen's d would equal 0.33, which would be between weak and moderate effect. Okay? And the way we would report this is we might say that there was a difference between pre-test and post-test scores. Then we would give all these numbers, and we would say that the post-test score, or in other words, the participant's pulse rate, was lower after 30 minutes with the therapy dog. And that's really all we have to say in the results. It's really straightforward. Okay. So now we're going to do another example. In this example here, an experimental psychologist believed that the training students received in his graduate program changed their ability to think logically. He gave a logical thinking test to 8 students who just entered the program. Then 4 years later, he gave the same students the logical thinking test again. It is predicted that there will be a difference in the number of errors between year 1 and year 4. The number of errors made by each student is shown. Okay, so here's the data table. Notice his hypothesis said there will be a difference. So that's a two-tailed test. He didn't say which difference it was. So now I went ahead and I inputted those data into SPSS right here. So here's the student number. Here's what they got in year 1, and here's what they got in year 4. Now just think, are 8 students a good sample? No, that's a terrible sample. We would need a lot more than this. But this is just an example. So now we're going to go again, analyze, compare means, paired samples t-test. Okay, don't worry about this variable, that's just their name. So variable 1 could be year 4 or year 1, variable 2 could be year 4. Again, it doesn't matter if you switch these, it would just change t from positive to negative, but you would still interpret it all the same way. Then we say okay, we go and we look at the output. Okay, here's our next t-test. So in year 1, their number of errors on average was 10.25. Here's your standard deviation. In year 4, the number of errors was 4.25. So the number of errors did go down. We can see that from the means. But was it significant? Don't worry about this table. Do not report the significance from this table. Pretend that one doesn't exist. So now down here, it did year 1 minus year 4. The difference was 6 points. So year 1 was higher because it's positive. Over here, t is equal to 4.2. We round it to 1, 4.21. Degrees of freedom was 7, and our significance was 0.004. We had a two-tailed hypothesis, so we report the two-tailed significance. So was there a difference between groups? Yes. So to report your results here, you would say there were fewer number of errors made in year 4 than there were in year 1. You would report those means and standard deviations, and then you would report t, parentheses 7, equals 4.21, comma, p equals 0.004. And then you would calculate Cohen's d, which in this case would be 6 divided by 4.03556, and that equals 1.48, which is a very large effect size. So that's all you do to report the results. In both of those cases, you would approach the discussion the same way you have always been approaching the discussion. Just talk about what implications these findings have, what are some possible confounding variables, what should we look at in the future, the same thing you've always been doing. So that's all I have for dependent t. It's really simple, like I said. So your next step would be to watch the repeated measures ANOVA lecture, which is when we have more than 2 repeated measures. So if you have any questions on this, please post them in the comments on YouTube or in the discussion forum on Blackboard.